This video will work through problem 7.3 from Gapenski's Healthcare Finance, 6th edition. Okay, in problem 7.3, we're presented with Allied Laboratories is considering combining its most common tests into a one-price package. And so they're trying to get some efficiencies here by doing all three tests at one time. If you combine the tests, you'll be able to get some efficiency. So you'll be able to do the test with a single syringe, a single form, a single Band-Aid, and then you'll have risk of one breakage fee. You'll need 2 vials to do the test, but you'll still need all 3 reagents because the reagents are unique to each of the tests. So you'll still have all 3 vials. So the combined test will have the cost of 1 syringe, 2 vials. So a vial costs 50 cents. So 2 vials for $1, 1 form. All 3 reagents, we have to add this up. 0.8 and 120 is 2, plus 60 is 260. 1 Band-Aid, because if you only get stuck once, you only need 1 Band-Aid. And then this is not necessarily clear from the problem, but we're going to assume we have breakage risk worth 5 cents. So if you add all that up, the expected price is $6.90. So that's part A, is marginal cost of $6.90. So when we talk about marginal cost, what we're asking is how much would it cost to do one more test? So in this case, to do one more combined test, all the individual unique costs to doing the test would cost $6.90. Now for part B, it asks if Allied wants a $10 contribution margin for each of these tests or test packages, how much would they have to set the price at? Well, if they want if their costs are $6.90 and they want a $10 contribution margin, then you just add $10 to the $6.90, and you get $16.90. So that's the answer to part B. And then part C asks if there's what would the full price be? So what's the break-even price at 2,000 tests? So a volume of 2,000, assuming that direct costs, fixed costs, are 40,000. So now we have the marginal cost of performing the test plus some fixed cost of 40,000, and that would most likely represent the cost of renting a machine to do the tests, maybe the salary for a lab tech to do the blood draws and run the tests. Regardless, we've got the $40,000 costs. And if we're going to do break even, then we have profit is equal to 0. So we set up our profit function where profit is equal to 0. We're going to have total revenue minus total costs. We have an unknown price, but we know that we're going to do 2,000 tests. So we'll have total revenue will be 2,000 times the price P minus the total cost, and the total costs will start with the fixed cost of 40,000 minus the variable cost, which is the 690, times 2,000 tests. So 0 profit equals 2,000 times the price minus 40,000 minus 690 times P. 690 times 2,000. 690 times 2,000 is 13,800. Plus $40,000 in fixed costs is 53,800. We're going to add the 53,800 to both sides. So we wind up getting 2,000 P equals 53,800. And again, that 53,800 is equal to the sum of the fixed cost plus the total variable cost. Then we just divide the 53,800 by 2,000, and we get price is equal to $26.90. Now, the second part of part C asks what price must be set to produce a profit of 20,000. So to do that, instead of setting profit equal to 0, we're going to set profit equal to 20,000. So 20,000 equals total revenue, which is 2,000p, minus the 40,000 in direct costs, minus the 690 times 2,000, which we calculated was worth 53,800. That doesn't change. The costs don't change just because we want a certain amount of profit. So we add 53,800 to both sides. We get 73,800 equals 2,000p. 73,800 divided by 2,000 gives us $36.90, a price of $36.90.